Hi, I'm Reese, and this is my submission on formative assessments. So to get started, let's define a formative assessment. So formative assessments are typically used while a unit of learning is still going on. So it could be mid-semester, could be midweek, could be midway through a particular class. But the goal of formative assessments is for both the teacher and the student to get some feedback on how well and how much the students are learning, and then adapt strategies based on what they've learned to improve learning in the future. These types of assessments are typically compared to summative assessment as the two major styles of assessment. And summative assessment is more final and conclusive and tends to happen at the end of a particular unit or semester or year of study. And so a summative assessment is pretty diagnostic in telling how well the student did and might have some implications for how the student should be placed in the future or things like that, but doesn't tend to have the same emphasis on what can I do to improve learning tomorrow that formative assessment tends to have. And I found this graphic that I really liked, which compares two stages of a chef preparing a dish. And the formative assessment is when the chef tastes the soup and they still have a chance to muck with it if they don't like exactly how it tastes. The summative assessment is when the chef brings the soup out, gives it to a food critic, and then their restaurant gets a grade. And so it's kind of a nice, easy way to really get at the difference between these two styles. So for this assignment, I'm going to share two styles of formative assessment that I've created. The first example was designed for a high school chemistry class, and this is part of a lesson where students are learning the historical progression of the atomic model. So starting with when we thought that atoms were just like tiny bits of sand, to developing more complex subatomic particles and more complex structure. And so that's a progression where the students need to know some highlights, but mostly we're building up to what the modern atomic structure looks like. And so the learning objective for this activity is for students to be able to explain and diagram the modern structure of an atom. And so you've probably seen an image, something like this one here, with a really classic image of an atom. And that's kind of what we're hoping to get students to generate. So this was designed to be an in-class small group assignment where each group, 2 to 3 students, can pick from a set of 4 activities and choose 2 to complete. And so I'll just do a brief overview on the 4 different choices. So the first is a concept map, where I've laid out a diagram and then given some vocabulary options, and the goal is for students to correctly drag and drop those word boxes into where they fit in the diagram. So they need to know what the relationships are between those pieces to fill this in correctly. The second option is to compare and contrast 2 of the subatomic particles. So the subatomic particles have very different behavior, and their behavior drives how we believe that the atom is structured. So it's important to know about them, and I wanted to provide this as an option for students who wanted to think a little bit more critically about the particles rather than just getting lost in the bigger structure. This option would allow students to create a diagram of an atom. They could draw it on pen and paper, take a picture of it and upload it, or they can use any sort of computer programming that they might be familiar with. But I've listed that it needs to include 4 components, which are the major subatomic structures that we're discussing. And then as a final option, for those who are more literary minded, I wanted to give them an option to kind of put what they're thinking in words. So one of the historical atomic models that we talk about a lot and that they need to know for their end of year test is called the plum pudding model, named because it has these little small pieces of negative charge in like a larger positively charged pudding. It's not the model that we believe in now, but it's kind of a useful analogy that helps students remember it for the test. And so I wanted to give them an option to create a new analogy that reflects the slightly more complicated modern atomic model. And so this assignment was meant to reflect a couple of different learning theories and strategies, namely the cognitive learning theory by providing multiple means of representation of kind of the same idea, which should provide multiple pathways for them to encode that information. And then I'm also hoping that it reflects the constructivist learning theory by giving students some autonomy in their learning, getting a little bit more of a self-directed and hands-on application of new knowledge. So the next assignment that I want to talk about was designed for a high school earth and environmental science class. This was designed to be an individual homework assignment, and this particular assignment would follow up a couple of lessons where we're talking about alternative energy. So we start off the discussion by defining energy, talking about what it is and how we use it, and then how we currently produce energy, specifically all about fossil fuels. And then this assignment would follow up one of the days when we talk about different alternative energy sources and get to know some more specifics on them. And at this point, students have completed projects where they've gone into more detail on individual alternative energy sources, but we haven't spent a lot of time comparing and contrasting them. And so the goal for this assignment is for students to compare alternative energy sources based on given criteria. And the specific criteria that are in the learning objectives is abundance and environmental impact. And so for this assignment, I decided to create what I've called the Energy Madness Tournament, which is kind of styled off of like a sports bracket. And I was able to use Google Forms to create that. So if you opened up the Google form, on the left you'll see how the first page is laid out, and on the right you'll see how subsequent pages are set up. And so what shows up on this first page is kind of an introduction to the assignment, the Energy Madness Tournament, and then you see this kind of bracket overview. So the first matchup that the students will be talking about is fossil fuels versus nuclear. And then whichever one of those they decide is better in terms of environmental impact and abundance will move on to this qualifier round. They will compare it with solar and then compare the winner of that matchup to geothermal, and then they will ultimately defend the champion of their tournament. So once they have gone through the basic instructions, they'll open up one of these pages. This is the first matchup that we have, which is between fossil fuel and nuclear energy. And so the first two questions are pretty straightforward. It just asks, does either of the contestants have a worse environmental impact than the other? And then, is one of the contestants more able to provide energy? In other words, is it more abundant than the other? So those are the two criteria that I'm having them analyze. And then once they've kind of thought that through enough to give a yes, no, maybe answer, excuse me, I ask which one they think is a better option overall in terms of those two factors. And it's just a brief explanation of 1 to 2 sentences. I didn't want to make it too long since they're having to do this 4 or 5 times over. So I'm hoping that this activity particularly reflects the constructivist learning theory by kind of tapping into a cultural phenomenon, the sports tournament style, that hopefully they'll all understand. And getting them to kind of activate their knowledge in a new way by comparing and contrasting things that they've mostly examined in isolation. So some of the particular strategies that I've employed for these designs, the first one, I really emphasize the choice and variety. Giving students a chance to pick a method that will work best for them to represent their learning, I thought would be really helpful in terms of getting the most accurate results. Especially since I hope to have summative assessments that reflect a variety of skills, I wanted to give them a chance to practice a wider variety. The mix of knowledge and skills was also important to me. So science includes a lot of skills like making graphs and charts and constructing well-founded arguments. And so I wanted them to practice in the first assignment their skills with modeling and creating diagrams. And in the second assignment, their ability to construct effective arguments and justify their beliefs. Another best practice that I implemented was to have a pretty low impact on their grades. So I didn't want them to be stressed out about how well they were doing on this assignment, because that wouldn't really give them the opportunity to take chances and really stick their necks out for a little bit of learning. So I chose to focus on comments rather than a numerical grade, and pretty much just gave them full points for participation, a very small percentage of their grade, to incentivize them to complete the assignment, but to focus on the learning that was happening. I also provided detailed feedback, which is key to improving outcomes and making sure that the students are actually learning from it instead of treating it more as a summative assessment where they dump all the knowledge they can and then they're done with it. I want them to feel that there is a sense of continuity between this and future assignments in the unit, and I wanted to provide feedback to correct any misunderstandings that might have happened along the way. And then finally, I think that both of these assignments really reflected the learning objectives that I'd set in place. Obviously, this is super important for both formative and summative assessments. If you're not testing what you think the kids should be learning, then you don't know whether or not they learned it. So I'm hoping that these matched up pretty well. So how did it go? The first one I have not implemented. I haven't been in a chemistry class yet. But one issue that I do foresee with implementing it is a possible reliability issue. So because students are getting to pick from different assignments, it could be pretty tough to compare. And if students fall back on their strong suits and don't push themselves to pick something that might be more difficult for them, it could be tough to really tell how well they understand it. For example, I'm really hoping that they're able to come out of this unit able to draw a diagram of an atom. And if they choose particularly two of the options that are more kind of verbal and compare and contrasting based, they might not actually have to practice that skill. So if I were going to implement it, I might need to tweak it a little bit, either make them do 3 out of 4 activities or maybe even pick different activities for different skill sets. And then in the second example, I found that it was a lot of work to grade. Even though I only asked for 1 or 2 sentences of explanation on each page, it ended up being a lot to go through, and there were a lot of misunderstandings that I needed to correct. Partially because I think I might have implemented it a little too early. They hadn't had a chance to practice in class constructing those arguments yet. So there was a lot of kinks to work out. I think that in the future, I would also try to program the Google form to automatically provide some of that feedback based on the things that they pick in the form, which is a super awesome function of Google Forms. It's just kind of time consuming to set up on the front end, but it would have saved me a lot of time in grading if I didn't have to repeat the same kind of basic things for every individual student. And it might have helped for them to get their feedback a little more quickly because it took me so long to grade that I couldn't actually get back all of the assignments by the time that they really needed to know if they'd mastered that information. So I would try to streamline and simplify it a little bit so that I could do a better job providing that detailed feedback. However, I did find it to be a pretty good predictor of understanding. I found that the students who did well on this assignment did well on the summative assessment at the end of the unit. And that the students who had pretty clear answers definitely had the best understanding of not only how to formulate an argument, but also of the different technologies that we were comparing. So while I might not have done as much as I should have to get those students who performed lower, to get them up to that higher level, it was interesting to see how it was reflected in future assessments. So definitely lots of room to improve for me. And so, sorry about that. There we go. So that's an overview of my 2 assignments, kind of what I've taken from this unit on assessment, and specifically formative assessment. And I really think that almost everything that teachers do could be considered a formative assessment. Everything from noticing what kids are working on in class, to answering questions to the class during a lecture, to homework assignments. All of those things can be forms of formative assessment if we treat them like that. And if we take the time to actually give students feedback on the everyday things that they're contributing to the class. So I hope in the future to be a little bit more mindful of how everything I'm doing can be seen as a formative assessment, and to make sure that I'm implementing some of these best practices more frequently. Thanks.